Hey there, this is Seth Schaefer from Team Cuz Robotics, and in today's video we're going to talk about the latest version of Division, which just fought in July's Norwalk Havoc event. This version of Division is what I'm calling version 2.12, I believe. Version 2.11 fought in May, and I've got a few minor tweaks and upgrades to it that are now for the July version. So I'm going to talk about what those were, and then in my full event recap that I'll release in a few weeks, you'll be able to see all of the fights and the damage I took and repairs I made, and talk to some of the competitors I fought against, and learn a lot more about what exactly happened in each fight, what parts of this worked well, and what parts of it didn't. But I'll talk at least a little bit about what worked better than last time in this video. So, I also want to make an announcement that I have a new website now where you can buy some custom designed PCBs that I've designed and made specifically for other people to have an easier time building small robots. So I have an all-in-one PCB or AIO PCB, which has an integrated switch, BEC, and power LED. I have a basic PCB, which can use a fingertech switch or any other switch, and is basically just to simplify and clean up wiring. And then I have my own custom designed PCB switch, which is kind of like a alternative to a fingertech switch and should work for 3-pound and other small bots. It can take 30 amps continuously for more than 3 minutes and bursts of 50 amps for up to 30 seconds that I've tested, but it might be able to do much higher currents for shorter periods of time. So this is what Division looked like right after the July event. It has some battle scars on it. This version is currently running, ready to go, and it fought twice. I also have my horizontal config that also fought twice, which has some damage that also has yet to be repaired after its last fight. So you can see here I have a similar fork setup to version 2.11 that I showed in my last overview video. These TPU side forks are new, however. They took some hits, but they handled those hits very well. You can see some scars. Definitely got a nice solid hit on the side here, but it kind of just carved a little bit of plastic out and the fork stayed intact, which is way better than what happened with the AR500 versions I ran last time. I also did have quite a bit of damage to the pulley here from one fight, but the belt never broke and it was still functional. So yeah, I didn't have any problems with the weapon motor for the most part. I had some electrical issues that I also worked to address, but for the most part, the bot held up way better than it did in May, and I'm pretty happy with it. Right, hopefully I can do this with the camera on a tripod here. So this is what the old hub looked like, or not old hub, but rather the one I tried in May. You can see it kind of presses into the wheel, and then these little fins are supposed to kind of stick out and grab onto the washer. The problem is that TPU is really flexible and these can bend quite a bit. They're not super rigid and that doesn't hold the washer on very well. And also TPU doesn't like to stick to hot glue very well, which is what I was kind of using to hold these onto the actual shafts. So they ended up coming off in a couple fights. So instead of these hubs, I am now running nylon, which is what I had run previously in other events. And this is Tallman's Alloy 910 nylon. And then to attach the hub or the washer, you kind of have to push it down. And then I have this special key that I designed and printed that's also included with the design that's for sale on my web store. You just kind of push it, turn it until the little locking features engage. And now this wheel will not be turning without this hub anytime soon. So it works really nicely, but the washer sticks out a tiny little bit, which means there's something for another vertical spinner or horizontal spinner potentially to hit, but it's not nearly as bad as having your motor shaft steel or like an aluminum hub sticking out, because in the past I had issues where the aluminum hub would get hit, that it transfers 100% of the shock load straight to the shaft and breaks the shaft or something. Whereas with these, you could have a cut that kind of carves through the washer, and worst case would be you kind of lose the washer. But the design of the hub is intended to be such that even if you do lose the washer, the wheel should kind of still be able to turn with the hub due to the little engaging spikes back here and the squish that it gets, at least from these little jutting out features. I tried to improve that with this version by making these longer and stick out further, but it kind of just compressed all the foam up further, and these, when this was turning, they kind of just ripped through it, so it actually was way worse, and I didn't like that. One other change was that previously, in May, I had just created this config with the anti-vertical config with these hinged forks, and I had fixed forks on the sides, but those used to be these. So this is actually a 1/10 of an inch thick AR500, and these are incredibly strong and rigid, but that turned out to be a detriment. Number one, when a vertical spinner did catch the tip of this, it bent it up permanently, and it could no longer get under things. Though the purpose of these forks isn't so much to get under things as it is to just prevent the robot from tipping forward on spin up. And number two, because they're so solid, when that did happen, this hit kind of took a hit and kind of bent up like this, it sheared this first screw in half so that the whole thing could kind of pivot backwards and get in the way of the wheel and stuff, or even pivot underneath and get stuck under the bot, which is terrible. So instead I now have a TPU version of that, which is much, much thicker. I think this is 3 times thicker than the AR500 version because TPU is extremely bendy compared to steel. And you can see that it has quite a bit of give to it, but that it pretty much springs back to where it was before, which is definitely preferable as opposed to having it get bent and stay bent, which is also a problem I have with the horizontal configurations titanium forks oftentimes. So using these seem to work out really, really nicely. The only problem I have with them is that for some reason the screw holes are like shifting around quite a bit, or at least they're too big, so this can kind of stay in a bunch of different angular positions. So at some point I might need to look into how to fix that. If you have suggestions for that, leave them in the comments. Otherwise, it didn't really get in the way too much. It just kind of made it so that if the bot tipped forward a bit, then like it drives around like this, which, I mean, it's not as stable as it would be otherwise, but it still can't tip forward, which was the main goal. So not a huge deal. So yeah, looking at the front of the bot, not a ton changed. Like I said, I kind of just went from this to this. But otherwise the forks retention system was exactly the same. I just have a shoulder bolt that goes through and threads into a nut over here. And that shoulder bolt would have to rip through a ton of plastic to get out, so that hasn't happened yet. So far it's been proving fairly robust. And on this side, at least, where the screw didn't rip through, it has no way to really get high enough that it will be stuck, which is definitely good. And it has quite a bit of downward travel as well. So the bot can be at a pretty severe upwards angle before it'll lift off the floor, and that's to make it so that when the bot is like gyroing and turning, I still have the forks tip on the floor. So that works pretty well as well. So this is what the anti-horizontal spinner configuration of Division looks like. This was kind of like the classic Division. This is what Division looked like from basically version 2.0 through to the 2.11 that fought in May. I pretty much only had this titanium wedge setup. So this is a 16th inch thick titanium that I bent on the edges to try and make a nice angled wedge, and it's served pretty well until it gets ripped off, like you can see happened on this side. But you'll have to watch again my event recap that I will release in a few weeks to see that fight in its entirety. Overall, this setup has been pretty rock solid. The wedges coming off has been a perennial issue in various different fights, and right now the main issue that I'm dealing with is just that these titanium forks are pretty easily bent. Like you can see, this one got really bent to the point where it almost lifts my drive wheel off the ground. That's something I still need to come up with a better solution for. I've tried a bunch of different forms of plastic and then this titanium, and I'm afraid to try AR500 because of what happened when I tried that on the sides. So I'm still gonna have some thoughts on that, and if you have suggestions, again, leave those in the comments. I'd really appreciate it. But other than these getting a little bent up, honestly, this configuration worked pretty well for me. This is exactly what it looked like after my last fight at Norwalk, and you can see there is not a ton of visual damage anywhere other than this being ripped off, and unfortunately my weapon motor came a little loose, so I couldn't keep spinning the weapon. So you can see on this side, there are kind of a card route along where the weapon pulley rides. So unfortunately it was rubbing against the pulley, and I think it hit off the pulley flange and then the belt came off. So that must have ripped the motor free when it hit the pulley flange hard enough to do that. That's the only time that that has happened with this new weapon motor and pulley setup though. So I think that there are some ways that I can address that in the future that shouldn't require any like huge changes, but hopefully I can prevent that from happening again. You can see here the horizontal spinner hit that took off that wedge. It came in at like the worst possible angle, where it kind of just started cutting just into the upright, and then it hit the side of the wedge like straight on with full engagement, and that's why it was able to tear it off. So if it were coming from this direction, it would have glanced off just like the hit here did, and not done anything. But because the robot was spinning this way, came in just at the right time and was able to knock off that wedge. So there might be something that I could do, like beveling this, that might do something to kind of prevent that, but honestly, I don't think there's a huge amount that I could really do about something like that. It's just a really unfortunate thing that can happen if the timing of my weapon coming around is just a little bit later than the timing of my opponent's. Alright, let's talk about weapons. Even though this isn't like a change for just this version, I think it's still something that's interesting to address and discuss what's the deal with all these different weapon designs. So historically, Division has run 4 different weapon designs. So I have this one, which is the newest one, which I call the Cutter Blade, and for the first time ever at this most recent Norwalk Havoc event, I only ran 1 weapon. I'm pretty sure in every other event, even if I've only had 2 or 3 fights, I have always run 1 weapon for one type of opponent and a different weapon for a different type of opponent. But this weapon was really designed to be kind of an all-around use weapon, and I'll talk a bit more about that in a little bit. But I ended up using this weapon in all 4 fights, even when I was fighting horizontal spinners and vertical spinners. So let's talk about the evolution of the weapon design. So I have here the 2 original weapons from the version 1 of Division, the very, very first version that ever fought. I have some videos of individual fights from that video on my channel, but I never made an overview of it because it sucked, and I redesigned the entire bot from scratch, basically other than the weapons and the electronics after that first version to make version 2.0. So version 1.0, 2.0 through I think version 2.6, I only had 2 different weapons. This disc, which is of course the logo for my channel, as you can see, and then this, what I call the S-Blade. So I basically just call this the disc, this the S-Blade. This was designed to fight horizontal spinners. This was designed for kind of everything else. So the reason this is better against horizontal spinners is because of what happens when the disc fights horizontal spinners, which is that. Against one particularly violent hit, the entire thing just bent. So couldn't use it anymore. I don't know why I ran the disc in that particular fight, but I did. This one obviously is way chunkier. It's much thicker here and here to support the weapon. It's basically almost twice the cross-sectional area supporting the tooth as one of the spokes on the disc is. And I also had issues with the disc where if a vertical spinner hit straight on here where it wasn't supported by a spoke, this whole part could dent in and unbalance it. So the disc was not an ideal weapon choice, but it had a huge amount of kinetic energy storage and a huge moment of inertia because of moving all of the weight towards the outside. So to try and get kind of a better solution, I went to this, which I call my Deep 6 asymmetric disc, or the triangular asymmetric weapon, I guess. So this one I moved as much of the mass to the outside as I could, but I have an asymmetric design now, which means I get twice the tooth engagement at the same rotational speed. So this weapon comes around and the tooth hits once per revolution, whereas with this one it hits twice per revolution. So if I'm going at 10 feet per second, then I get twice as close to the enemy before a tooth hits them with this weapon as I do with this one, which means the tooth engages twice as far into them and I can hit them into the air more effectively or rip into them more effectively. So asymmetric weapons have a lot of obvious benefits. This one's seen quite a bit of combat and is still in very good shape. The overall spoke strength here is a little bit stronger, and these supports help a lot more in this configuration than they do in this configuration to take horizontal hits. So this weapon should in theory have been considerably better against horizontal hits, and I have yet to significantly damage or break one of these fighting both vertical and horizontal spinners. You can see this little notch here from the S7 tool steel tooth of voxel hitting into the AR-500 slightly softer steel of this weapon. All of the weapons on Division, by the way, cut out of 1/4 inch thick AR-500 steel, and I would recommend my sponsor Send Cut Send to cut weapons if you are into that. You can also purchase a 2D CAD file that you could send straight to Send Cut Send for both this weapon design and for the cutter blade design on my website if you're interested in doing that. I also have an extremely in-depth spinner weapon design series video and a second video following it up that explains everything that went into designing this weapon, and pretty much all the same thought went into designing this newer cutter blade. So the main difference between this weapon and this one is basically the tooth geometry in terms of how effective it is. As you can see, I kind of blended these two designs to end up with an aggressive rake angle. So rake is basically, if you draw a line from here to the tip, the angle at which this tooth is past that line is the rake angle. So positive rake angle of 25 degrees on this one, whereas this, if you draw from the center straight to the end of the tooth, you have a 0 degree or neutral rake angle. And I believe with this one it's exactly the same, just a 0 degree neutral rake angle. So the positive rake angle on this makes it a lot better at biting into softer armor like plastic and aluminum and kind of ripping into it. And a lot of bots that I've been fighting have been made out of plastic or have some plastic armor. So if I'm gonna try and target an area that's softer on a robot, using an aggressive sharp tooth like this or like this is usually a good bet. So by having an aggressive tooth and having the ability to take horizontal hits a lot better and having the extra bite of an asymmetric weapon, this weapon can kind of do it all. Now, it's obviously not going to be perfect for every single possible opponent, and maybe I'll design another weapon in the future that would be like to take on the absolute most powerful horizontal spinner or the absolute most powerful vertical spinner or something and optimize it really specific to that. But this weapon seems like it's been doing really, really well against all kinds of opponents that I've fought so far. So I'm going to be sticking with this design for a while, and I now have 4 of these that I can use when one gets dull or too banged up. Here's a closer look at what the cutter blade looks like in its unused, freshly painted form. This is one of the newer ones that I got that hasn't actually been in a fight yet. So yeah, if you're interested in getting a weapon just like this or just like this, and you could rescale it to your liking, you'll get access to a full 2D DXF CAD file by purchasing the digital designs for this guy or this guy, and you could upload that into Fusion 360 as a sketch and then modify it to your heart's content to make it a smaller diameter, change the bolt pattern, change the bearing size, or whatever you'd like. So yeah, that's all I have for you today. Definitely check out the new website if you're interested in downloading these designs. And I also have my PCB boards for sale, which I will release another video in the future about this all-in-one PCB board, which I already have one on my channel you can look for the basic one. The all-in-one board is basically all the functionality of the basic board, plus it has a built-in switch that's kind of like a fingertech switch. And it has a built-in BEC, so you can power your receiver off of it, and it has a built-in power LED, so you can see when it's turned on. All of those things together for 15 bucks. This basic board is $6.50, and it basically is just power distribution between a battery and 3 other XT30 connections that I recommend going to a weapon, drive side 1, drive side 2, and then it breaks out to where you could plug in a BEC, or if you're running a 2-cell battery, you might be able to plug directly into your receiver, depending on the receiver voltage limits. And of course, I also have my PCB switch, which is exactly what it sounds like. It is basically a power switch that should work with pretty much any 3-pound robot. It can handle easily 30 amps continuous for more than 3 minutes. and it can handle bursts of over 50 amps for about 30 seconds, and anything else in between that will probably not be seen in a combat robot, or else if you're running XT30 connectors, they would have melted if you're running a 3-pound robot. So yeah, that's all I have for you today. If you have any comments, let me know down below. If you would like to check out links to my spinner design video series focusing on how I made this weapon, I'll have links to that in the description as well. I'll probably be pretty busy prepping for BattleBots in the coming weeks, so there might be a lot of radio silence for a while, but hopefully I'll have my event recap video out before like August 20th, I hope. But I can't make any promises just yet, because I need to get parts for Bloodsport and Retrograde ready. So yeah, if you liked this video, make sure to click like. If you want to see more videos like this, make sure to subscribe and hit the bell icon for notifications. And as always, thanks for watching.